Hello everybody. Today I will talk you about Kubernetes monitoring, why it is difficult and how to improve it. Let's meet. I'm Aliaksandr Valialkin and our Victorimetrics founder and co-developer. I also known as Go contributor and author of popular libraries for Go, such as FastRCP, FastCache and FixInPlate. As you can see that libraries start from fast and quick prefixes. This means that these libraries are quite fast. So I'm fond of performance optimizations. What is Victorimetrics? This TimeSeries database and monitoring solution. It is open source. It is simple to set up and operate. It is cost efficient, highly scalable, and it is cloud ready. We provide Helm charts and operators for Victorimetrics for Kubernetes. According to recent surveys, from this survey, for instance, you can see that the amounts of monitoring data increases 2-3 times faster than the amounts of actual application data. And this not so good. For instance, some people in Twitter also notice it and say that this is not so good because monitoring the costs for storing monitoring data all increases much faster comparing to costs for storing application data. According to the recent CNCF survey, many users of Kubernetes struggle with the complexity and monitoring issues. As you can see, 27% of these users don't like the state of monitoring in Kubernetes. So why Kubernetes monitoring is so challenging? The first thing is that Kubernetes exposes big amounts of metrics on itself. You can look at this link and see how many Kubernetes components expose huge amounts of metrics. And the number of these exposed metrics grows over time. Let's look at this graph. This graph shows that the number of unique metric names which are exposed by Kubernetes components has been grown from 150 in 2018 in Kubernetes version 1.10 to more than 500 in Kubernetes 1.24, which has been released recently. The number of metrics, unique metrics which are exposed by applications grow not only in Kubernetes services but in any application. For instance, node exporter component, which is usually used in Kubernetes and for monitoring hardware, also increases the number of unique metrics. For instance, the number of metrics in node exporter increased from 100 to more than 400 in the last 5 years. Every Kubernetes node exports at least 2,500 series, and this doesn't count the number of application metrics. These metrics include node exporter metrics, kubelet, and the advisor metrics. And according to our study, we see that the average number of such metrics per each node, Kubernetes node, is around 4,000. So if you have 1,000 nodes, then you will have your Kubernetes cluster will expose 4 million metrics which should be collected. What is the source of such big amounts of metrics? This is because of multi-layer architecture of modern systems. Let's look at this picture. You can see that hardware server contains virtual machine, and each virtual machine contains pod, and each pod contains applications, and each application contains container. And all these levels must have some observability. This means that they need to expose some metrics. And if you have multiple containers in Kubernetes, multiple pods in Kubernetes, then the number of exposed metrics increases with these numbers of pods and containers. Let's look at the simple example. When you deploy Nginx, 3 replicas of Nginx in Kubernetes, they already generate more than 600 new time series, according to cAdvisor. And these metrics don't count application metrics. This means that metrics which are exposed by Nginx itself. Another issue with Kubernetes monitoring is time series churn, when old series are substituted by new ones. And monitoring solutions don't like high churn rate because it leads to memory issues, memory usage issues, and CPU time issues. Kubernetes tends to generate high churn rate for active time series because of 2 things. The first thing is frequent deployments. When you deploy a new deployment, then a new set of metrics for the deployment are generated because every such metric usually contain pod metric, and this pod metric is usually generated automatically by Kubernetes. And another source of high churn rate is pod autoscale events. When pods scale, then new pod names appear, and metrics for these new pods should be registered in monitoring system, and this generates high churn rate. And the number of new metrics which are generated with each deployment or pod autoscale event can be estimated as the number of container stat metrics for this application, for each instance of this application, plus the number of application metrics. And this number should be multiplied by the number of replicas for this deployment and the number of deployments. And as you can see, if the churn rate increases with the number of deployment and the number of replicas. Do we need all these metrics? The answer is not so easy, like you see. Some people say that no, we don't need all these metrics because our monitoring systems uses only a small fraction of the collected metrics. But others say yes, we need collecting all these metrics because these metrics can be used in the future. How to determine the exact set of needed metrics? There is a Mimir tool from Grafana which scans your recording and alerting rules, and also scans your dashboard queries and decides which metrics are used and which metrics aren't used. And then it can generate a whole list for used metrics. And for instance, Grafana says that if you have a Kubernetes cluster with 3 nodes, if this cluster exposes 40,000 active time series by default, And if you run Mimir tool and apply allow list to labeling rules, this allows reducing the number of active time series from 40,000 to 8,000. This means more than 5 times less. So what does it mean? This means that existing solutions like Kubernetes Prometheus stack collect too many metrics, and most of them are unused. This chart shows that only 24% of collected metrics from Prometheus stack are actually used by alerts and recording rules and dashboards, and 75% of metrics never used by current monitoring solutions. This means that you can reduce your spend expenses on monitoring solution by 76%. That's more than 4 times. Let's talk about monitoring standards. Unfortunately, there is no established standard for metrics at the moment. Community and different companies try to invent own standard and promote them. For instance, Google promotes 4 golden signal standard. Brendan Gregg promotes use standard for monitoring, and Weaveworks promotes red standard. But so many different standards leads to the following situation that nobody follows a single standard, and everybody follows different standards or doesn't follow any standard. This leads to big amounts of metrics in every application, and these metrics change over time. And you can read many articles and opinions about most essential metrics, and there is no single source of truth for monitoring. This also leads to outdated dashboards for Kubernetes at Grafana. For instance, the most popular dashboards in Grafana are now outdated in Grafana. And Kubernetes provokes you to generate, to use microservices architecture. And microservices architecture has some challenges. Every microservice instance needs to own metrics. The users need to track and correlate events across multiple services. Ephemerality of the services also makes situation worse. Ephemerality means that every microservice can be started, redeployed, stopped at any time. And because of this situation, new entities like distributed traces needs to be invented and used in order to improve the observability situation for microservices. Microservices talk to each other with via network, so you need to improve networking to monitor networking. Service allocation on one node create a nosy neighbor problem, and this problem also needs to be solved. And service mesh introduces yet another layer of complexity which needs to be monitored. How Kubernetes affects the monitoring? As you can see from previous slides, Kubernetes increases complexity and metrics footprint. Current monitoring solutions such as Prometheus, Victory Metrics, Tanos, Cortex, and 3DB are busy with overcoming complexities introduced by Kubernetes. The most complexities are active time series churn rate, which are generated from ephemerality of as a service and huge volumes of metrics for each layer and service. Developers of current monitoring solutions spend big amounts of efforts for adopting existing monitoring tools for Kubernetes because of this. Maybe if there was no Kubernetes, we won't need distributed traces and exemplars, because distributed traces and exemplars are used solely for microservices and Kubernetes. And maybe if there was no Kubernetes, all this time overcoming difficulties in current monitoring solution could be invested into more useful observability tools, such as automated root cause analysis or metrics correlation. Who knows? How Kubernetes deals with millions of metrics? The answer is that Kubernetes doesn't provide good solution. It provides only 2 flags, which can be used for blacklisting, dissolving some metrics and allowing other label values. That's not so good solution. How does Prometheus deals with Kubernetes challenges? Actually, Prometheus version 2 has been created because of Kubernetes, because it needs to solve Kubernetes challenges with high number of time series and high churn rate. You can read the announcement of Prometheus version 2 in order to understand how they redesigned internal architecture of Prometheus solely for solving Kubernetes issues. But still, Kubernetes issues such as high churn rate and cardinality aren't solved in Prometheus and other monitoring solution actually. Victorymetrics also deals Kubernetes challenges. Actually, Victorymetrics has been appeared as a system which solves cardinality issues in Prometheus version 1. It is optimized for using lower amounts of memory in disk space when working with high cardinality series. It also provides optimizations to overcome time series churn, which is common in Kubernetes. And Victorymetrics also, we at Victorymetrics also don't know how to reduce the number of time series, and Victorymetrics, new versions of Victorymetrics increase the number of exported time series over time. You can see that the number of new metric names which are exposed by Victorymetrics growth around 3 times during the last 4 years. And only 30% of these metrics are actually used by Victorymetrics dashboards and alerts and recording rules. How can we improve the situation? We believe that Kubernetes monitoring complexity must be reduced, and the number of exposed metrics must be reduced. The number of histograms must be reduced, because the histogram is the biggest offender of new, which generates many new time series. The number of parametric labels must be reduced. For instance, in Kubernetes, it is common practice to put all the labels which are defined at pod level to all the metrics exposed by this pod. And probably this is not correct. We should change the situation. Time series churn rate must be reduced. This is the most common time series churn rate source in Kubernetes is horizontal pod autoscaling and deployments. And we should think hard how to reduce churn rate for these sources. And we believe that community will come up with a standard for Kubernetes monitoring, which will be much lightweight and we will need to collect a much lower number of metrics compared to the current state of monitoring of Kubernetes. So let's do it together. Now you can ask questions.